Hello students. At present, we all are crossing through a very tough time. The whole world is facing a challenge, that is COVID-19. And you know, the only method or the only way to get rid of this challenge is to stay home. We are in a stage of lockdown for nearly 1.5 months. So naturally, we are detached from our regular classroom. This is a try to bring you back in the teaching and learning process.
This video is made for the students of class 8 and I am going to discuss about density. If equal volumes of different substances such as wood, iron, zinc, water, glycerine, mercury, etc. are weighed by a physical balance, we find that their masses are different. The mass of iron is much more than the mass of an equal volume of wood. This is because the particles of iron are heavier and more closely packed than those of wood. In other words, iron is denser than wood. In a similar manner, if we take equal masses of cotton and lead, say 1 kg each, we notice that their volumes are different. The volumes of cotton is much larger than the volume of an equal mass of lead. This is because the particles of lead or iron are closely packed while those of cotton are very loose. In other words, lead is or iron is denser than cotton. Thus, to explain that equal volumes of different substances have different masses or equal masses of different substances have different volumes, we use a term called density. So, density is defined as the density of a substance is its mass per unit volume. So, mathematically, we can say that density of a substance is equal to mass of the substance by volume of the substance. It is a scalar quantity and is represented by the letter rho or d. If mass of a substance is m and its volume is v, its density is rho equal to m by v. Now, the question appears, what is the SI unit of density? We know that the SI unit of mass is kg and the SI unit of volume is meter cube. So, the SI unit of density is kg per meter cube. In SI system, unit of mass is kg and unit of volume is meter cube. So, SI unit of density is kg meter to the power minus 3 or kg per meter cube and its CGS unit is gram per centimeter cube. Now, if we find the relation between SI and CGS unit of density, by the process of conversion, we will find that 1 gram per centimeter cube is equal to 1000 kg per meter cube. We will now read that what is the effect of temperature on density. Most of the substances expand on heating and contract on cooling, but their mass remains unchanged. Therefore, density of most of the substances decreases with the increase in temperature and increase with the decrease in temperature. But there is an exception. The exception is water. The behavior of water is very different due to its uneven expansion. Water when cooled from a high temperature contracts up to 4 degrees Celsius. Thereafter, it expands below 4 degrees Celsius up to 0 degrees Celsius. Thus, the density of water gradually increases when it is cooled up to 4 degrees Celsius and then starts decreasing when it is cooled further below 4 degrees Celsius up to 0 degrees Celsius. Thus, the density of water is maximum at 4 degrees Celsius and it is equal to 1 gram per centimeter cube or 1000 kg per meter cube. Now students, how we can find the density of some objects? Now if the object is a regular solid body, then we can easily find the mass of the body by a digital balance, and the volume of the body can be found by its mathematical formula. For example, if you think of a solid cube, we can find the density of the solid cube by finding the mass of the body and dividing it by its volume, which can be found by length into breadth into height or by side into side into side. So this is very easy to find the density of a regular body. But if the body is not a regular one, if it is an irregular solid, for example a stone, in that case the mass is found by an electronic balance. Then how to find the volume? To find the volume of that irregular body, as we cannot directly apply its formula, so we have to take a measuring cylinder and we have to take some water in it. As you can see in the figure, in the first measuring cylinder, we can find the level of water is nearly 48 ml or centimeter cube. Next, when the irregular body is placed inside the measuring cylinder, naturally the level of water will increase, as you can see in the second figure. So here we find that the level of water has increased at a level of 60. Now if we subtract the second level value minus the first level, that is V2 minus V1, we can find the volume of the irregular object which is immersed in the measuring cylinder. Thus we can find the volume, and then by dividing the mass with the found volume, we can find the density of the irregular solid. Students, now we will learn what is relative density. We have read that density of water at 4 degrees Celsius is 1 gram per centimeter cube or 1000 kg per meter cube. Treating it as a standard, the density of a substance can be compared with the density of water at 4 degrees Celsius, and the ratio so obtained is termed as the relative density of that substance. Thus, the relative density of a substance is the ratio of the density of that substance to the density of water at 4 degrees Celsius. Students, you can find the expression of relative density, that is RD, as it is given on the screen. Now, density of the substance means mass of the substance by volume of the substance, and density of water of same volume means mass of the water by volume of water at 4 degrees Celsius. Ultimately, we will get the expression of relative density as mass of the substance by mass of an equal volume of water at 4 degrees Celsius. Students, as you can see here that RD, that is relative density, is a ratio of density of a substance by density of water or mass of the substance by mass of equal volume of water. So it is a ratio. That is, it has no unit as it is simply a ratio of two densities or masses. Now we will find the relationship between density and relative density. In CGS system, density of water at 4 degrees Celsius is 1 gram per centimeter cube. So the relative density of a substance is equal to the numerical value of density of that substance. Again, in SI system, density of water at 4 degrees Celsius is 1000 kg per meter cube. So its relative density is, as you can find on the screen. So students, here is a worksheet based on today's discussion.
So students, we have come to the end of today's topic and hope you have got a brief idea about what we have discussed today.